When designing classes for an application, one will often model a class and then realize they need a more specialized version of that class. So let me give you an example here. Let's say we had a vehicle class. And we might say, well, all vehicles have an odometer value. And I don't know, maybe a model year. Okay, but then you start to realize, well, there's different kinds of vehicles. There's, oh, I don't know, a car, there's a space shuttle is a type of vehicle, a unicycle is a type of vehicle. Right, so we would maybe create classes for those. Right, these all have something in common. They really do all have, say, an odometer value and a model year. Okay. It's kind of a shame to take the code in the vehicle class and copy and paste it in the car, the space shuttle, and the unicycle. So inheritance allows one to build additional functionality based on an existing class. Okay, and inheritance will allow us to not have to copy and paste code in related classes. Inheritance allows developers to reuse common code between similar but not identical classes. Okay, and what we do is we push the common parts of the set of classes into this thing called a base class, and we extend the base class with additional functionality. Okay, so now what we would have is a vehicle class with that odometer value. Okay, and this we call this is the base class. Okay, what we could do from this base class is we can inherit. So we can have a car class. We can have our unicycle class. And we can have our space shuttle class. Okay. These we call the derived classes. Okay, so I'm going to use these terms base and derived. The base is the class that you're inheriting from. The derived classes are the classes that are built from the base class. So the derived classes absorb everything from the base class. All the data, all the methods, and they can be extended to include new data and new methods. So for example, in the car class, we might add this method to pop the hood. Right? That's very specific to a car. Not all vehicles have a hood, but a car does. In the space shuttle, we might have a method to, I don't know, blast off. Okay, in our unicycle class, might have a pedal method. Okay, so the derived classes, not only do they absorb everything from the base class, you can add additional stuff, additional data, additional methods. So the relationship between a car and a vehicle is that a car is a vehicle. We say inheritance is a relationship. This is true because the car absorbs everything that a vehicle is. A car is a vehicle. All of the public methods and public data members of the base class are public in the derived class. And we'll talk about a few other rules later about access to certain data and methods. Every car object has the data and methods of the base class. They can be used with regular plain old dot notation. So in this pophood method. So public void pophood. If for some reason we wanted to get the odometer value, okay. If the vehicle class provides a getter, okay, then all the derived classes absorb not only the piece of data for the odometer, but also the methods that go along with the base class. Okay, so if for some reason we wanted to, in the derived car class in the pophood, if we wanted to get the odometer value, we can do that. We can call the base class method, and we kind of get this for free. So in Java, we achieve the inheritance relationship using the extends keyword. Okay. When I draw these little pictures of class diagrams, this open diamond or this open triangle is going to represent inheritance. So the arrowhead is always going to be on the class that we're inheriting from, and the derived classes are down below. Okay, so syntax-wise, like I said, we will do something like this. Public class car extends vehicle. And then we can write our code in here. Now, C++ also has this ability to inherit, but the syntax is a little bit different here. This is Java, and in C++, the way we do it is we would say class car, and then we'd use this colon, indicates inheritance, and then we'd say public vehicle. Okay, so I think the Java syntax reads a little bit better. I think that's true of just about everything we compare Java to C++. I think Java just reads better. Okay, so when we use inheritance, the goal is to push the commonalities of a set of classes up the hierarchy to get a maximum amount of reuse. Okay. Then in the derived classes, we only have to specify, well, what's different. And that's what inheritance is all about. Inheritance is all about reusing code. And turns out there's no limit to how far one can push the inheritance relationships. So if we have before we had our vehicle and car class. Let me do this again here. There are different types of cars. There's maybe a SUV car, and there's a sports car. Okay. So as you go down, the classes become more and more specialized. They become more and more specific. We don't need to know any of the details of the implementation in order to inherit. We only need to know about the interface. And in fact, we don't even need the .java file. We only need the corresponding compiled .class file. Okay. If the base code then is fully tested, we really only need to test the new functionality we add in our derived classes. If there's a bug fix or a better implementation in the base class, all we need to do is recompile, and we kind of automatically get those fixes or changes for free. Okay, so inheritance allows us to describe a car as a vehicle. Not only is this convenient, but it's absolutely correct. the car receives the public interface of the vehicle it inherits from. Okay, so again, in our little situation here where we have the vehicle has the odometer, and every car has this ability to pop the hood. Okay, what we can do code-wise is we can do something like this. Okay, this is vehicle V. This is a reference to a vehicle. Now you can only call methods of the class vehicle with this reference. Okay, but one thing you can do is you can say V is equal to a new car. Okay, you can make the vehicle reference point to a car object. And this is okay because remember, a car is a vehicle, and it has all the methods in the vehicle class. Okay, so what that means is we can say v dot get odometer. Okay, this is perfectly fine. Again, because the car inherits the vehicle's data and methods, including the get odometer method. The one thing we cannot do, though, is we cannot say v dot pop hood. Okay. In fact, the compiler will give you a syntax error if you try and do that. Okay, so basically what's happening here, the compiler checks the type of the reference. Okay, in this case, the reference type is vehicle, and complains because the vehicle class does not have a pop hood method. Okay, since Java uses references that can be changed to point to many different objects, right? The reference is just a pointer. The compiler cannot know at compile time whether the reference is pointing to a car or a vehicle or a space shuttle. So the compiler says, well, we're not going to let you call the pop hood method. A reference to an object exposes the public interface of that class. So a vehicle reference, so with a vehicle reference, we can only call vehicle methods or ones inherited from a parent. Okay, since a car inherits from a vehicle, we can use a vehicle reference to hold the address of the car object. That's fine. Then we can use the public interface of the type of reference, a vehicle, on the object. Okay, and again, this is okay because a car is a vehicle. Let me give you another example. Let's say we're going to have an array list of vehicle references called vehicles. We of course know we would do this to create an array list of vehicle references. And then we could use vehicles to add some objects. So maybe we'll create a new car object. Okay, and remember whenever you say new car, it's going to go create room for a car object on the heap and return the address of that to be stored inside the array list. Array lists always hold references. They never hold actual objects. This is a little bit different than in C++ with the vector. The vectors do hold actual objects, but in Java we always hold references. Here we'll create a new space shuttle, and we'll store it on the vehicles collection. create a new unicycle. Okay, so if we were to look at memory right now, we have a car, we have a space shuttle, and we have a unicycle. Right? And we have this array list that is actually pointing to this collection where each one of these is really a pointer. Okay, so vehicles is the local reference to a array list object. The array list holds all these pointers that actually point to objects on the heap. Okay, so what we could do now is we could march through this collection. So for each vehicle in the collection called vehicles, we could say system dot out dot print line, and we could say vehicle dot get odometer. Okay, so they all the vehicles, the car, the space shuttle, and the unicycle, they all have this ability that they inherited from the vehicle class, this ability to get the odometer value. Okay, now another interesting thing we can do with inheritance is we can override methods. So when using inheritance, it's possible to override methods in the base class. Overriding takes place when a derived class method has the same signature, okay, basically the same name and parameters as a base class method. Okay, so let's do another example. Well, let's pretend we had this class called foo. And the foo class has a method called print. And inside here we'll just system.out.print something. And we'll print that we're inside foo. Okay. Now we can have another class that extends foo. We'll call this one bar. Okay, and if we have another method that is called public void print inside the bar class, well, since bar extends foo, we're overriding the behavior of the print function in the bar class. And this time we'll say inside bar. Okay, so we've overridden the method print in the derived class, and really there's a little hint we can give to the compiler. Whenever we override a method, we can do this little annotation to say that we want to override. Print is going to be an overridden method. Now, an annotation is not required. This is just a hint to the compiler that we're overriding. The compiler, though, will, if we include this annotation, will make sure that we really are overriding a base class method. If not, it will issue a syntax error. So again, it's not it's not strictly required, but it's a good idea to use these little annotations in our code. Okay, so let's look at the driver now. Okay, so let's say we had this public static void main function inside some class, some driver class. Okay, what we could do is we could say foo f is equal to a new foo object, and bar b is equal to a new bar object. Okay, and if I say f.print, okay, what you're going to see on the screen is, like you might expect, inside foo. And if you say b.print, okay, this is the interesting part here, because b has overridden the print method. Instead of printing inside foo, what it's going to print is inside bar. Okay. So we overrode the behavior from the base class in the derived class. Okay, now let's talk about the object class. So if a class does not explicitly extend another class, it automatically extends this class called object. Okay, so before, when I said public class vehicle, it doesn't appear that I'm extending any other class because I haven't used the extends keyword. But this is exactly equivalent to public class vehicle extends this class called object. Okay. The object class is at the root of all inheritance hierarchies. Every single object that you create in Java is an object. It comes from this object class. So really, the picture I drew before was that we had this vehicle class, and we had the car class extend the vehicle class. But in reality, there's another inheritance relationship here. Okay. Every single class in Java has the object class at its root. Okay, so let's see. We can do a few things here. Let's create a couple objects. So we'll say car C is equal to a new car. Okay, and now I'm going to create a vehicle reference V, and I'm going to set it equal to the result of casting C to be a vehicle. Okay, so in Java, this is how we cast. We give the type that we want to turn the reference to in parentheses right beforehand. Now I mention this because you can always safely cast up the hierarchy. Okay, so what I mean here is we have this car object down here. We can cast the reference type to be a higher class in the hierarchy. So here I call this casting up. Okay, so the vehicle reference points to a car object, and this is okay because we know a car is a vehicle. So this is perfectly valid. And in fact, we could even say v.getOdometer. Okay. Again, we always look at the type of the reference. The compiler looks at the type of the reference to determine what we can do with the object that reference points to. So the car object inherits all the odometer information from the vehicle class, so this will work just fine. It's not always safe to cast down, though. Okay, so let me show you an example of that. Let's create an object called obj. So it says the reference obj is going to point to a object on the heap. Okay. Now if I were to do this, car C is equal to the cast value. So here I'm casting obj to be a car. So and I'm storing the result in C. So the reference C of type car now points to this thing that is an object. Okay. So we had the object and we're casting down to be a car. This is not safe, right? If I did something like this, C dot pop hood, we would have a big problem because we know this object doesn't have the ability to pop a hood. However, this would compile. So the compiler lets us cast references to any type that we'd like, but when we're casting down we have to be very careful because we don't know for sure that that object actually has the required methods. Okay, so what would happen is if we were to run this code, an exception would get thrown here because the plain old object doesn't know how to pop the hood. Okay, now let's look a little bit at this object class. Okay, so we'll see it's a fundamental class. It's in the java.lang package. And it says class object is the root of the class hierarchy. Every class has object as a superclass. Okay. All objects, including arrays, implement the methods of this class. And you'll see this has been around since the very first release of Java. Okay, since all classes have object at their root, they all have these methods that they inherit. Every single class that we have in Java has a clone, an equals, a finalize, a hash code, a toString. Okay. Let's talk a little bit about these, starting with toString. toString is a method that returns a string representation of an object. By default, the object class's toString will return the name of the class the object belongs to and the address in memory of that particular object that you're calling toString on. So that's by itself is not very useful. You can and should, in just about every case, override the behavior of toString and provide a more meaningful string representation. So the car class might override this method with a string with the make and the model and the year that it was made. We also have this method called equals, okay, where whenever we call equals, we always pass in another object. Okay, so if you ever intend to compare two objects for equality, you don't want to use the double equals operator. That will just compare the addresses of the references. Okay. Instead, you override the equals method and provide some kind of policy for deciding that two objects are equal. For example, if you had an employee class with a first name and a last name, an address, a social security number, you'd want to say that two employee objects are the same only if the social security numbers are the same. Because at a large corporation, it's possible that two different employees have the same name, and it's even possible that two employees have the same address. Okay, but clearly they're different employees. Just because two people have the same name doesn't mean they're the exact same human being. So the equals method should be overridden to compare just the social security numbers. Okay. So that would work something like this. Okay, equals always returns a Boolean. And it always takes a plain old object, which in this case I'm going to call other. So when we're comparing two things, there's this object that we're comparing to and the other object. Okay. So I'm going to initialize this return value to false, meaning that the passed-in object is not exactly equal to this object. I'll check to see, well, is the other object not equal to null? Right. Okay, so if they do pass in a null pointer, we want to just return the default false value. Okay, next we have to do a little check on the type. There's this keyword instance of, which if you give it an object, the keyword instance of and the name of a class, okay, it will tell us, is this object really an instance of this class? This happens at runtime. So this is a runtime check to make sure the passed-in object really is an employee. This is, again, remember, a generic object. If this is in the employee class and we pass in a space shuttle, well, that's never really going to be the case that those two things are equal. So this checks to make sure the types of the objects are the same. Okay, so only if this is true do we need to compare any further. And we might say, okay, remember this is supposed to be the employee class. So if we get the Social Security number, which maybe is a string, and we ask for the other object's Social Security number. Okay, so this is just a comparison of the two Social Security number strings. If that's true, then we can change our return value. Okay, and then we can fall out of here and finally return the return value. Okay, now there's one thing I didn't put in here. Other, remember, is a plain old object. So we're going to have to cast that. So I'm running out of space here, but pretend this cast what came right before the reference to other. Without the cast, the compiler would complain because other doesn't have this object doesn't have a get Social Security number, even though we know for sure it is an employee. Otherwise, this wouldn't have been true. So this always checks: is this object, is the reference or the object pointed to by this reference, is it really an employee? If so, we know for sure it has a get Social Security number. So the cast just lets the compiler know that we know this is an employee object and it's safe to call the Social Security number method. Okay, so now that we have an equals method, if we have some employee objects, let's say emp1 dot equals emp2. Remember, these are both pointers to employee objects, right? And they each have a Social Security number. Okay. All this is doing is checking, are these two Social Security numbers in fact the same? And the equals method will now return true if those two employee objects that are pointed to by emp1 and emp2 actually have the same Social Security number. Let's see, there's another method called hash code. So if you plan on using your objects in a hash table of any kind, then you should override hash code. So remember, a hash table's a way to very efficiently store and retrieve values. And it always comes in this key value pair where we hash on some key to get a slot in some kind of an array, and that's where that object is going to be stored. So hash code must return an integer that's used to identify like I said, a kind of a bucket location in a hash table. And if two objects are equal to each other, that is, their equals methods return true, then they should return the same hash code. So if there's a field or fields that identify an object, you should use those to build the hash code. This might be as simple as something like this. Okay, so again, in the employee class, we might have a public int hash code. Right? We decided that the social security number was going to uniquely identify each employee. And the social security number is a string. And the string, because it also is an object, it actually should be get social security number. That'll return a string dot hash code. Okay, so the implementers of the string class have figured out how to generate a unique value based on a string. All we have to do is pick out the data members that uniquely identify, in this case, the employee, and we will return the hash code of the string that identifies employees. Okay. So now, any two employees, if they're equal, they will return the exact same hash code because we know they have the same social security number. There's another method called clone. This will create and return a copy of an object. Okay, clone is used to copy objects. By default, a shallow copy of an object is made. That is, a new object is returned, but any references in it points to the objects in the original. And you can override this behavior. That was the default behavior. You can override this to make something called a deep copy of the object, to copy not only the objects but the references that those objects point to. Okay, so this will probably make more sense if I draw a picture. So I'll start with what it looks like to create a shallow copy. And again, this is default behavior. So let's say we have an object here of type foo, and foo has these two references, A and B. Okay. A is pointing to some other object, and B is pointing to some object here. If you were to call clone on this foo object, okay, what's going to happen is we are definitely going to get a copy of the original object. Okay, and this object has its own references A and B, but they're going to point to the existing objects from the original. Okay, we call that a shallow copy. Sometimes that's okay, but sometimes we want a deep copy, meaning when we copy the object, we want copies of all the pointed to objects as well. So if this is our foo object, again with A and B, okay, if we override clone, we could make it do something different, like not only create a copy of the object itself, but create copies of the objects that A and B point to. This is called a deep copy. So this happens by default. If you override clone, you can specify that you want to create those new deep copies.